This is question 50 on chemistry from the 2020 IMAT. So we're asked, in which pair of the following species does vanadium have the same oxidation state? So how do we determine oxidation states of a metal? So we need to use the rules that we know already to work out what the oxidation state of vanadium can be. Of course, because vanadium is a transition metal, it can take a variety of different oxidation states. So looking at our first pair, what is the oxidation state of vanadium in VO2? Well, one of the rules that we need to use is that oxygen always has an oxidation state of -2, unless it's in a peroxide. None of these are peroxides, so we don't need to worry about that. We can always assign oxygen as -2. So in this case, what does that mean for vanadium? So we have 2 times -2, taking us down to -4. Then, to make a neutral species overall, vanadium therefore has to be +4. Now, is vanadium also +4 in VO3-? So again, using our rule for oxygen, we have 3 times -2, taking us down to -6. Then, to make a -1 charge overall, vanadium has to be +5. So we can see that in these two, vanadium does not have the same oxidation state. Now, what about our second pair? So VO2 we've already done, but how about V2O5? So we have 5 oxygens taking us down to -10. And therefore, to get back to 0 overall, each of these vanadiums has to be +5 to give +10. So once again, we have +4 and +5, so not the same oxidation state. How about pair C? So in VCl4, we need to use a different rule. And what is that? So chlorine, being a halogen, generally takes a -1 oxidation state, unless it's bonded to oxygen, which it is not. So what does that mean for vanadium here? We have 4 chlorides taking it down to -4, and so vanadium has to be +4 to make a neutral species overall. Now in VO2+, we have an oxygen giving us -2, and so to get from -2 to +2, vanadium has to be +4. So in C, it looks like they do have the same oxidation state, but let's just check our last two quickly to make sure this is definitely our final answer. So looking at D, we have VCl4 that we've already done, and VO3- that we've already done. And once again, we can see these do not have the same oxidation state of vanadium. Then what about E? We have V2O5, which had a +5 vanadium, and VO2+, which from before had a +4 vanadium. So we can see that using our rules, the only pair in which vanadium has the same oxidation state in both species is C. So this is our final answer.